Hello everyone. On behalf of Columbia Global Centers Mumbai, I would like to welcome you to our first live stream event. The Mumbai Center is one of Columbia University's 8 global centers, and we serve as a knowledge space that works with researchers and academics at the Columbia University N, as well as local partners and networks here in India to jointly address global challenges. Today's webinar, When River Becomes Machine, is part of our ongoing work on water access and management. Do stay engaged with us for all our knowledge and research activities on groundwater issues. I would like to welcome Professor Anthony Acciavatti from the Graduate School of Architecture, Planning and Preservation at Columbia University, as well as Professor Vinod Tare, who has joined us from Kanpur. He is the founding head of the Ganga River Basin Management and Studies at the IIT Kanpur. I will hand it over to them.
Thank you, Madhvi, for that introduction, and thank you, Dr. Tare, for joining us here today at the Columbia Global Center in Mumbai. It's great to have you here. I'm looking forward to the conversation. And also very much looking forward to the discussion we're going to have with some of our participants or our viewers at the National Institute of Hydrology, Roorkee, as well as the JJ College of Architecture. So the format will be that I will give a kind of 10-minute kind of presentation on my work, and then Dr. Tare and I will have a conversation about Ganga more generally, and also some of the specifics of the river basin, and then we'll open it up to questions from our viewers. So the work I'm going to share with you today is drawn from a 10-year-long project that I published recently as Ganges Water Machine. This project looks at the Ganga River Basin from a number of viewpoints. It starts really quite literally from Gangotri Glacier at Gomukh, that you can see here, goes through the Gangetic Plains, where I took over 25,000 photographs. And the book, like the exhibition that's currently up here in Mumbai, ends at the historic city of Varanasi. The majority of the work that I do focuses on the state of Uttar Pradesh, which is an incredible laboratory, or has been an incredible laboratory for water management intervention really since the 19th century to the present. And one of the arguments that I make both in the book and in the exhibition is the transformation of the Ganga River Basin into a vast water machine. The Ganga River Basin, of course, is primarily in India, but also it covers parts of China, Bangladesh, Nepal, Bhutan. Ganga River Basin is one of the largest or not one of the largest, but one of the most highly constructed or engineered supersurfaces in the world in terms of its engineering. This image here looks at the Ganga River Basin, and the top, or the first kind of gray image, the second from the bottom, is the Ganga River Basin itself. The red drawing immediately above it is the rain-fed agriculture in the basin, and just above that, all of that black, if we zoom in here, is literally all of the irrigated agriculture that exists in this region. So it's one of the most hyper-engineered, not just in terms of canals, but also tube wells, hand pumps, and step wells, and a number of other pumping mechanisms that exist here. Oftentimes, we think of this area as being defined by the Great Ganges Canal system that, when it first opened in 1854, was 1,300 kilometers long. Today, it's over 12,000 kilometers long if we take the upper and lower Ganga Canal system. And if that's a kind of monumental project, then the tube well oftentimes is defined as being this highly decentralized miniature technology. And in the work that I'm going to share with you, I certainly look a great deal at these two technologies and the way that they've interacted with each other really since the introduction of the tube well in the early 20th century. As I was mentioning before, the Ganges Canal System first opened in 1854, 1,300 kilometers long, longest canal system in the world when it first opened, 5 times the length of all of the canals in Lombardy, Italy, and Egypt combined. And this canal system begins at Haridwar and works its way through Siwalik Hills down to the Gangetic Plains, where it enters the Gangetic Plains at Roorkee, where it crosses the Sulani River via the Sulani Aqueduct. And this canal system was really put in place to replace such decentralized technologies like you see here of step wells that catch the monsoon's waters, or say the Persian wheel and the pagoda. The British East India Company instituted the Ganges Canal System in order to supposedly thwart mass famine that was happening within the Ganga Jamuna Doab, but is in sense, since has been extended extensively across the Ganga Jamuna Doab. Today, that system is highly layered by a decentralized system of water management, and in particular the tube well. Tube wells are oftentimes very hard to find within the Gangetic Plains in terms of being out in the open. Oftentimes, they're covered or hidden, though you find imagery for advertisements for tube wells like you see here on the right-hand side, this being from Crompton Greaves, just in central Uttar Pradesh in the Ganga Jamuna Doab. And while there's a great history of the government sinking many of these tube wells, bringing this technology, especially to the village, and then it providing water for India's green revolution, it's also very much tied to India's urban revolution as well. And I look at this a great deal in the work that I do in the book. Here, oftentimes this is an image from the 1970s for Punjab National Bank, where you see a Punjabi farmer with wheat over his shoulder, someone spraying DDT, a tube well in the foreground, and then a tractor in the background, these being oftentimes the 4 major components of the Green Revolution. But oftentimes when we find a tube well, it's generally housed in something similar to this. One can hear them more often than you can see them. Especially in UP, they're oftentimes diesel-powered and not electricity-driven. But these hand pumps and tube wells dot the landscape. We find them, say, here on a farm in eastern UP, or here in the city of Kanpur, right next to this Dukanwala and a set of water buffalo being housed within the city. And what I argue in the book and the exhibition is that this is not a technological succession of, say, highly centralized to decentralized, but instead it's a process of layering these competing technologies with one another. And sometimes they in fact work together in the form of, say, conjunctive irrigation that one finds, especially along certain areas of the Ganga canal system, and certainly with the upper Bari Doab canal in the Punjab. And I think one of the kind of best or most succinct lines that I've ever found is from a historian who says that urban forms have a direct correlation with infrastructural norms, which is to say that infrastructure and urban development are very much tied to one another, just as much as infrastructure is with, say, agriculture. And the work that I do in studying the Ganga Basin is not just looking at its infrastructure, but also very much looking at the incredible dynamism that exists in this landscape. Dynamism, by that I mean both the dynamism of population growth, but also the dynamism of the Ganga via the monsoons. And part of the work that I've done then is to develop what I call a dynamic atlas, a way of including or layering the dynamism of the Ganga in its many forms, including people that live along its edges and within its larger region, as well as the incredible amount of infrastructure that's there to temper the dynamism of this river. So I do that by looking in particular at an area between Allahabad and Varanasi, where I look at, say, the traditional urban core of a city like Allahabad or Varanasi, and then the area between it, or look through it at a series of swaths that I'll show you here. And what I do is combine cartography with photography in order to map out, not just give a certain precision to this landscape, but also to show the way in which people inhabit this and develop a choreography with the monsoons and certainly with the movement of vast amounts of soil within this area. So this is a drawing of Allahabad and Varanasi. The bottom part of the drawing that you see here is of Allahabad turned 90 degrees counterclockwise, showing how Ganga expands and contracts over a single year. The darkest tone of purple is when Ganga is just pre-monsoon, most shallow, and then the lightest purple is when Ganga is at its extreme. And here you can see just the variability in the kind of splotch and stain versus a kind of rivulet almost that exists within the bed of the Ganga. But I also then document those same tones of purple. I photograph at the Sangam how this area changes over time. So these are a set of panoramas beginning with Magh Mela, where here you can see at the very bottom of this panorama, we have the temporary tent city, which I know you've been working on for quite some time in terms of dealing with the sanitation and infrastructure. And that, of course, is quite an amazing undertaking unto itself to provide that level of infrastructure for a temporary town. But what's also quite amazing is that that same infrastructure, when the tent cities are pulled up and the toilets and all of the running water, farmers move in and use the grid of the city for agriculture. And then they harvest their crops over time. And then the monsoons come in and wash all of this away. And this happens every year. And that cycle is something that's incredibly well designed. There's a level of design intelligence, I would say, there in terms of incorporating the dynamism of the Ganga that we can really learn a lot from, not just through writing about it and qualifying it in terms of quantifiable data, but also very much visualizing that data, visualizing how people live in this area and how it changes both with the cycles of the monsoon, but also how it's historically developed as well. And so I take these same techniques and I also look at how, say, it's quite spectacular with Magh Mela here in 2006, or of course the Kumbh Mela in Allahabad in 2013 with the 80 to 100 million pilgrims that come to this area. And while we all know this spectacular image of the Kumbh Mela, what's also quite incredible then is that after this tent city is over, it turns into this, where we're looking at the same area we're just looking at in a set of photographs where farmers move in, they use the grid of the city. The water table level is so high that they don't even have to dig more than half a meter to then irrigate their crops, harvest their crops, and then all of this is washed away with the monsoons. Here you can see the tattoo of the tent city that's still left imprinted on the sandbars that eventually will be washed away with the coming of the southwest monsoon. And this area is not just for agriculture and for economic purposes, but it's also a space for irrigation, or sorry, for recreation as well. Here you can see water buffalo swimming along with bathers, people conducting pujas, sailing, etc. There's an incredible multiplicity of events that happen in this area. And for me, it's quite important as an architect and historian of science and technology to include that information, the drawings we make, and the way we talk about these spaces, so that we can better develop design proposals for dealing with some of the most urgent matters that are facing the basin today. And of course, these are also spaces where sand mining happens as well. And I take that same method of mapping and do that with a series of what I call transects, or swaths of land. And map that area as a set of areas perpendicular to the edge of the Ganga River. So these are 6 examples of those transects where I look at the layers of hydrological infrastructure, of human settlement patterns, of roadways, of tube wells, of the movement or shifting, or rather the dynamism within the Ganga bed itself. And so I do that by looking at those 6 areas in terms of, say, here the layering of Ganga in terms of how the river expands and contracts within its bed in those 6 transects, the level of roadways that exist in this area, the settlement patterns that are here, the surface water bodies, so all of the tanks, lakes, plumes that exist here, and then of course all of the nalas and canal systems that are within the area. And then I take all of those layers and put them back together, combining them so we can get a visually rich understanding that's very much a measured set of drawings of this area, to hopefully then imagine alternative futures for this area, then of course we'll have to go in and develop much more refined and detailed data points to better understand how we might manage this dynamism, especially in terms of the Nalas where a great deal of the pollution enters the river. But really trying to imagine and hallucinate how we can use drawing to better understand this area and develop policy, because of course words and numbers are so crucial, but where words and numbers leave a gap, I think maps, images, visualization, and animations of this area are quite critical to how we start to foresee the future of what is one of the world's most dynamic but also incredible river basins. So maybe I think with that, it would be great to have a conversation with you about the work that you've been conducting for quite some time now. Really, you've been involved with Ganga, at least since Ganga Action Plan onwards, so you have a great deal of knowledge about the basin, and it would be wonderful to talk with you more about the importance of representation and mapping in a context like this.
Well, I really find your work. It's really a great work, and particularly that you have research for yourself, and that too using very simple techniques. Representation is a very important thing. And I think the way you have presented it is really very good. It's going to be very useful. You have, of course, very rightly pointed out that Ganga in itself is a natural water machine. But to that, we have added number of artificial machines.
Sure.
Okay? In the form of taking water from the Ganga through the canal network, and then that water getting into the groundwater. Of course, in an area different than what Ganga would have done on its own.
Sure.
Okay? And then people using that water directly from the canals as well as groundwater. Okay? And in fact, today we can say that in the Ganga Basin, about 70% is through tube wells,
Yes.
and only 30% is directly irrigated through this thing. And at one point of time, we used to have a feeling that if you line the canal, then there will be less losses of water. And there were proposals earlier actually to line the canals. But today we have changed that thinking. Now we believe that canals are one of the ways through which we can recharge the groundwater. And that is how that water is available. And one of the challenges in managing the waters of Ganga is you are aware that the rainfall pattern is very unevenly distributed. We get water rainy days roughly about 30 to 40 days in a year, and all the water that we have goes into the channel, goes into the sea. And what we would like to manage the water properly, what we need to do is to convert that rapid flow into a sluggish flow, right? And this rapid flow has become more because we have changed the land use pattern. Okay? We have cut trees so that the forestation, the forest cover is less. As a result, we have more landslides. We have more silt coming into the things, right? So one of the challenges that we have is how do we make sure that the rapid flow is converted to sluggish flow. Okay, so that is one thing. And what we are thinking is we should be using this machine more carefully, and to the extent possible use the natural canals which we have lost. And how we can make sure that the water that we get during the monsoon gets circulated within those.
Sure.
And so we are able to store that water more in the groundwater. And then that groundwater flows back into the river, and we have more non-monsoonal flows. Okay, that is. But yes, your work is very important, and something similar now with more advanced techniques we are trying to do in the Ganga Basin. Okay, And in fact, typically, if you look at the problems of the Ganga Basin, you can say up to Haridwar, the problems are of different kind.
Sure.
Between Haridwar and Varanasi, the problems are of different kind. And as you go down Varanasi, they are a different kind. In the upper stretches, we are actually more worried about the continuity of the river, okay, longitudinal connectivity,
sure.
so that there is movement of biota. Because when we are talking about river is not just a canal which carries water. It's not just a conduit of water. It allows flow of several things, including biota and sediment.
Sure.
In fact, if you look at the entire plains of Uttar Pradesh and Bihar, they are created through the material that comes from Himalayas and gets distributed into the plains, right? And that is how this whole land is so fertile. Okay, so it's very important that we maintain that flow. Okay, and it also has a lot of economic aspects. In fact, Ganga is supporting in big way in our economic growth,
sure.
and particularly to the poor people of the country. Okay, that's right. And of course, as you suggested, culturally, it's very important. Okay, and in fact, this is one of the things our minister always says, that how many people, and particularly those who are needy, get supported when we have these cultural and spiritual activities on the bank. So, example, there is an economy of Kumbh Mela in itself, and that economy actually supports the needy people. Okay? And similarly, every year that Magh Mela that we have is again supports the needy people, and that's how the people get connected to this. We are definitely facing problems with this system now, right? Because as you showed, many places the groundwater table is higher during the non-monsoon. Recently, we have done the mapping, and many places we find that the river has become a losing river. That means the non-monsoon flows seeps into the ground, and that's one of the big issues that we have. And in addition to that, of course, the pollution is concerned.
And it's, I think, something that both of us are, we've talked quite a lot about off camera too, is the importance of understanding the layers, right,
yes.
of Ganga. That, we were mentioning people are just as crucial, right,
yes.
to understanding Ganga as are the aquatic life, the sediment, etc. That we can't divorce one from another. This idea of nature versus culture, they're so intertwined in a context like this.
In fact, actually, traditionally we are used to living together. And in fact, I do not know whether you are aware, the very purpose of the Kumbh Mela is to think about rivers. Okay, so this is a kind of Mela that we have. It's like a conference on Ganga. So people in different stretches, different places like our saints and Rishi Munis, right? They would study about the river, and then they will collect at one place and think about the river, okay? And then pass on that message to the common people, okay? How they should respect river, why we should worship river, how the river should be treated. So it was more a kind of scientific. It's a different thing that now we see it in a different way. It has become more a business. Kumbh Mela has become more business, but original idea of Kumbh Mela is very scientific, to think about river, to respect river, to ensure that the rivers are managed properly.
So then do you think that there's a need for having more events that draw people's attention to the river, to its importance to the life of the river beyond
yes,
the business
I
transaction?
think connecting people to the river is one of the most important things. And in fact, many people may not agree, but even in this Namami Gange program that the government has, and the Prime Minister's vision is why we have allocated money for creating ghats, cremations and things like that. The idea is that people get connected to the river, right? When they go to the river, okay? And the idea is people, but then people should not be misusing the river. Right?
Sure.
And more and more things they should be made aware of what are the things that are required and how it is important for their own survival, the river is. In fact, this is what we have looked at. If the Ganga is healthy, you can say that the people in the basin are healthy. Okay, so Ganga, the main channel of Ganga, is an indicator of the health of the basin in itself. So if Ganga is healthy in terms of flow, in terms of the biodiversity, aquatic life, and in terms of the water quality, we can in general say that the catchment area, that's the basin, is doing reasonably well. And if Ganga is dying, if the river health is not maintained, that also means there is something wrong with the basin as well. Okay? And the activities that we are planning in the basin are not going to be sustainable if the river health is not maintained. And this criteria, is getting more and more acceptable now, and that's why people are worried about the health of the river.
And how difficult do you think it's going to be to convince people that Ganga doesn't just end within the banks of what we see as the channel of the river, but really is connected to the groundwater that really forms a larger watershed, that the sanctity of Ganga extends well beyond just the banks of the river itself?
Well, that's certainly very tricky, because that part is hidden, and common people are not so easily able to connect that. Okay, that what is the consequences of withdrawing water through tube well, just because the tube well technologies are available. In fact, you can say that this is something that the tube well technology, on one side, yes, it has definitely improved our agriculture and other things, but this in a way has actually had an adverse impact on the river itself. Okay, so there's a great effort that is required to communicate this aspect, that if you are taking water from a tube well, you are actually taking water from Ganga. Okay, it is Ganga's water. That's river's water for that matter. And I think we need to do a lot in terms of communicating that with the people, right? Whether it is farmers or whatever, right? So it is not just if you are taking water directly from the river, you are taking river water if you are doing, and this is also true with the industries.
Sure.
And that's the reason why we are saying that the industry should follow the practice of reuse and recycle. Right? It's not that they are throwing their waste into the river, which is polluting the river. That's one aspect of it. But the quantity of water available in the river itself gets affected by their pumping the water from the adjacent area through the tube well techniques. Right?
And what about all of the privately owned tube wells that exist in cities, for example?
There is absolutely no account of that. In fact, this is another thing that we have suggested to the government, that we must have a detailed investigation into how much water is being pumped through the various tube wells. Okay? And in fact, this is one of the things that we have suggested, that for each town, at least to start with, we must start doing water balance. Okay, that how much water is supplied and how much of that gets generated in the form of wastewater. In fact, our estimation of wastewater also goes very wrong, because we don't know how much water is supplied. It's only we account for water that gets supplied through the public sources, public water supply scheme. But much of the water in the Ganga basin, people take it through this. Of course, slowly and slowly we are now getting into the policies where we are saying that it is only the piece of land is yours, but something below that is not yours.
It's a common property.
It's a common property. So now, slowly and slowly, of course, yet we have not come to the level where we have made this as a law. We are implementing it. But I think in times to come, this will come, that the groundwater, like the surface water, is also a common property.
Yeah.
Is not a private property. And that will be an important driver for making sure that the rivers are improved, the health of the rivers is improved, and then the water comes into the river.
Well, one of the things that you and I have had the chance to discuss earlier today was how much of the issues confronting Ganga today are also very much tied to urban questions, right? And you were mentioning before issues of land use, and it's a funny thing, or a kind of multi-layered set of issues, that the tube well allows you to kind of sink and extract groundwater almost anywhere, right? So there's almost a certain oasis mentality that its owners have, that you can sink it and do what you want with the water. But then also that's allowed for sediment patterns to extend to areas that previously they were not in. So you certainly have areas that are becoming less and less able to recharge groundwater because of the levels of impermeable surfaces. So because of the population density, for me as someone who's trained as an architect and urban designer, it's fascinating that it puts such a level of pressure even at the scale of architecture itself, because building footprints in a context like, say, UP, where over 200 million people live, is incredibly important. Trying to think about that in terms of groundwater recharge as much as issues of tube well access or groundwater recharge, say, in agricultural fields, etc.
In fact, that is a big challenge right now. What we are doing is we are importing water from long distances, whether it is horizontally or vertically, and converting that water into sewage or wastewater. And many of the channels or natural drains that we have, they actually used to flow dry during the non-monsoon period. And when they used to flow dry, slowly and slowly, because for 8-9 months, that space was empty. So people have started encroaching onto that, right? And those drains have become narrower and narrower. On the top of it, we discharge our wastewaters into it. And then they start stinking. And the moment they start stinking, people want to cover them. This is what has happened. And then we have a new phenomena called urban flood.
Right.
Because when these drains are encroached, that space is not left. And then whenever we have precipitation, rainwater, many of the urban places get flooded. Okay, and we have not really worried about the waterway, because when we built up rail, road, infrastructure within the cities, of course, or between the cities, that part is not really taken into consideration. And so what we need to do is, we are talking about interlinking of rivers. But in my way of looking at it, we should be thinking about interlinking of drains and water bodies within the urban spaces, and make sure that those drains and water bodies are maintained in a healthy fashion. And I think for each and every town, if we do that, I think Ganga will automatically get it. So if you ask me what should be done as an action in the towns, the first thing that we need to make sure that all drains that we have flowing through the city, their waterway is clear, they are interconnected, and the water which is not going to the water bodies should be going into that. And we should reuse and recycle. We typically say that India is becoming more water stressed, right? And we quote these numbers that before independence or just after independence, the water available per person was to the tune of 5,500 cubic meter per annum per person. And now we say that we have become a water stressed country, and that number has come to 1,500, 1,600 or so. But if you look at it, the total amount of water that is coming into the catchment has not changed.
Sure.
That remains same. So what has changed is the denominator. The population is increased. Okay, and so if you really want to meet the demand of the people, we have to recycle the same water 5-6 times. Sure. Right? And that is where the importance of recharge. But we have to be very careful when we are talking about recharging. We want to recharge good quality of water, right? Not recharge through sewage. And unfortunately, what is happening is for 8-9 months, whatever recharge that takes place through the drains in which the sewage is flowing, and that is actually enhancing the water quality problem. Okay. And one issue that I will mention to you is about the arsenic. Arsenic, the sources of arsenic are geogenic, no doubt about it. But the release of arsenic gets enhanced if we are not careful in terms of managing our sanitation, agriculture, and industrial waste, because that leads to the biological activity in the upper zone, and then that leads to the change in the geochemistry, like redox potentials go down, and then that releases the arsenic into the, and arsenic becomes more mobile. And as a result, we end up solving a wrong problem. Okay, first we create a problem, and then we worry about how to remove arsenic from the ground. So arsenic, which is arsenic, iron, which is sitting quietly in the sediment, the release is enhanced through anthropogenic actions, be it mismanagement of fecal sludge or septic tank effluent or whatever.
Yeah, and so how do you, well, it's quite a difficult problem then to, when you have such, on the one hand, centralized technologies like the canal systems, and then you have a level of decentralization with tube wells and them being a completely unregulated economy, right? Anybody can sink a tube well almost anywhere, or even if you're not allowed to, people oftentimes find ways around it. How do you imagine going forward, say, with municipalities being able to provide adequate drinking water so that fewer people depend upon tube wells in, say, cities and towns? Because, for example, I know in 2001 estimates ran as high as 100,000 privately owned tube wells existed, say, in the city of New Delhi. We probably know that's much, much higher back then, and of course even higher today. And one of the reasons is because the municipality is unable to provide adequate pressure and or potable water. How much of that is also at issue here too, in terms of addressing the needs of larger concentrations of people, and what the city and state governments can do about that?
See, very important thing is, as a country, as a nation, we have not been able to understand the value of water. We have not valued water. Now forget about pricing of water. And unless until the water is valued, and then it is incorporated into our financial planning, and make sure that those people who can pay for it, they are priced for it. Okay, like for example, typically in industries, what for we use the water? Water is essentially used to move things from one place to the other. Okay, and if you want to wash leather, why do you need Ganga water? Why can't you use recycled water, right? And that means we have to ensure whether people are taking from tube well or from publicly supplied water. The price of that has to be higher than the recycled water. And unless until, or in other words, we incorporate into the pricing the cost of bringing the water effluent to the same quality as that of fresh water. Now, nowhere we are taking into consideration that. Slowly and slowly we have to learn, and this is one of the things that has happened. All sewage treatment plants were saying they should go into the public-private partnership. And what we are saying is, you take sewage and treat it, and we purchase the treated sewage of a particular quality. We then will understand what is the value of it, and we'll also learn to pay for it. And the price of the fresh water should be typically higher than the price of this one. But there is also, people say, oh, it's a psychological thing, people don't want to use treated sewage. But countrywide, if you look at it, okay, Ganga Basin in particular, what we are actually doing directly or indirectly, knowingly or unknowingly, we are recycling water. Like, for example, you take the case of Yamuna, okay? Downstream of Delhi, there is not even a drop of fresh water that remains in the river during the non-monsoon season. So all our downstream towns, Mathura, Vrindavan, Agra, what they are taking? They are actually taking wastewater, and they are, in the name of Yamuna water, they are taking wastewater and treating it and reusing it. So almost everywhere, even in Kanpur, what we have is a lot of things that is coming in from the upstream side, and we treat that water and reuse. So I don't think this issue of psychological thing is not good to reuse, recycle, because we are already doing that.
So, and I think on that point, it'd be great to introduce, now that we can take some questions from the National Institute of Hydrology at Roorkee, as well as the JJ School of Architecture. here in Mumbai, who are all logging in remotely. And what I'll do is I'll read some of the questions out for both of us, and then we can address whoever the questions addressed to. So we have one question from our Please go ahead.
Institute of Dr. M.K. Goel. How you have correlated the Ganga system with the machines?
Could you repeat that question just one more time, and then I'll repeat it so everybody can hear?
Correlated the Ganga river system because the topic is Ganga water machine, you can say.
Yes.
Right. So in what terms you call it a machine?
Sure. So the question was, calling Ganges water machine. What's the context in which I use that term machine? So Ganges water machine is actually a term that two professors, one Professor V. Lakshmi Narayana at IIT Kanpur, along with Professor Roger Rave from Harvard University in 1975 special issue of Science magazine, defined the Ganges water machine as the larger Ganga basin and its ability to actually its potential to store groundwater or store the monsoon's waters in groundwater. And so they spoke about it as one of the Earth's great water machines in terms of the ways in which water moves through it and its potential to store it. Yet they claimed that it was, in fact, underutilized. I look at that machine in terms of the level of infrastructure that's been put in place to temper the Ganga is so immense, as I was showing in that drawing before, with all of the canal systems, with all of the tube wells, with all of the hand pumps. This is one of the most not only irrigated parts of the world, but just the level of infrastructure probably competes with some parts of Tokyo or even New York in terms of how engineered this surface is. In terms of directing water, either from pulling it up from groundwater or directing surface water bodies. Oftentimes when I think people talk about this, and I think Dr. Tare will probably agree with me, in the context of India and certainly abroad, the Gangetic Plains is oftentimes not spoken about as being highly engineered or full of infrastructure. If anything, when I'm in Delhi, people tell me that they think it's a backward place that's lacking infrastructure, but in fact, it has an incredible wealth of infrastructure. Now that infrastructure as a machine might not always be working, perfectly one another. It's maybe more akin to, say, like a political machine that doesn't always work at high efficiency. But I do think thinking about this landscape as a machine is incredibly valuable in terms of understanding its inputs and outputs. I don't know if Dr. Tare might also have something to add to that as well, because I know he's used the term machine to describe it as well.
Basically, I mean, if you look at any of our ponds or any of the artificial things that we build up, we lift the water and then let it flow through a conduit and then it is distributed and used further. So Ganga allows you to do that naturally. Okay, so every year in a hydrologic cycle, right? The water falls at a very high level in the Roorkee glaciers or wherever, and from there it transports many things, including water, silt, sand. Okay, so that way you can say it works as a machine, and then it goes down into the groundwater, and then it gets stored, and then of course we have added several machines to it in terms of tube wells and pumps and things like that.
Yes, thank you for that question.
Good afternoon. This is MC Ghosh. I work with groundwater. So I have also read about the Ganga water machine. So definitely what I understand is it is basically before monsoon, one has to create aquifer storage space to induce the flood water into the aquifer. And then recover the water subsequently. So what I have understood is, so once Ganga enters into plains, means after Haridwar, actually most of its potential head difference is lost. So thereafter, we do not have much potential head difference. Number one. Number two is, if you see the development of groundwater in Ganga Basin, it is about 60%. 60% of total groundwater resources in the Ganga Basin is explored. 40% still remain. So, and we do not have in the Ganga Basin uniform aquifer, subsurface aquifer space, subsurface space. In some places we have depleted groundwater, and some places we have the problem of, say, arsenic problem and fluoride problem, and also the problem of say iron. So in that case, in those areas, withdrawing the groundwater, means extracting the groundwater, is not advisable, because then means where all those water will be transported. So the area where we have the safe aquifer, means safe groundwater resources, there one can create some aquifer space. Now the question is, the seepage rate and the rate of flow in the river, they differ tremendously. So in that case, how one can retain the surface water for the aquifer recharge, right? And what we have seen is your vertical recharge is more effective than the horizontal induced recharge.
Yes.
So if it is so, then in what way you say that in the Ganga Basin, the Ganga water machine or Ganges water machine will work? And do you have any plan for that? So this is my question.
So the question, if I were to paraphrase that question, it would be that you're saying that the Ganga Basin works much better in terms of recharge vertically instead of horizontally, in terms of recharge by means of surface water bodies. Is that correct? And the need to concentrate those surface water bodies to then vertically recharge it. Is that a fair way to put your question? Yeah. So what I would say to that is that one of the things that I certainly found and study a lot in my book on the Ganges water machine are the myriad step wells that exist in this area, and all of the tanks, tals, kunds that exist, say, especially a city like Varanasi that Dr. Tare was mentioning earlier. And I think those are all really critical infrastructures in terms of recharging groundwater, that there's going to be a need to not only rehabilitate many of these step wells, where oftentimes you will find great numbers of hand pumps and tube wells within their periphery because they naturally raise the water table level so much. So I certainly think that those technologies that have largely been abandoned since canals and certainly since tube wells in a lot of places in UP and Bihar will definitely need to be revisited, but also then to develop, I think, zoning for new developments that take into account how do you vertically recharge aquifers so that you don't have so much area in terms of land use that's covered by impermeable surfaces. And this is again a kind of urban question then, I think, or at least a human settlement question in terms of how do you address population growth and sprawl within these areas so that you can still also ensure that groundwater is recharged adequately in terms of balancing that act between extraction versus replenishment. Interestingly, I would say enough, in Western UP, it's oftentimes water tables are dropping dramatically, whereas in, say, Eastern UP and Bihar, there's more a shortage of access to groundwater than there is actually water table levels dropping. There's been any number of rural economists who have looked at this issue, especially, I would say, in the Eastern UP and Bihar regions. But definitely, how do you build in water recharge is, I think, really crucial to especially new developments. And how do you reactivate all of those baulis and step wells that exist within the larger gangetic plains is crucial. I don't know if Dr. Tare has anything to add to that.
I think this is one exercise that we need to do is to figure out which are the potential areas where the recharge is very high. And then, I think that's kind of mapping that we need to do in the whole Ganga basin, that which are the regions where we can, the recharge potential is very high. And then to ensure that if we can circulate flood waters into those regions. I think this is an exercise that we need to do. And second thing that we need to do is recycle the water again and again. Okay, so that way we can get out of this, what we call it as water stress. Okay, so if the same water is recycled at the local level, and if we can interconnect the water bodies, because many of the water bodies have lost their catchment area because of the infrastructure that we have built. So whatever natural precipitation that was rainfall that was flowing into those water bodies, we have lost that. And as a result, we have encroached into those water bodies because it is not filled with water. So I think it is time that we identify all these water bodies, okay, and to the extent possible, make sure that through artificial network, okay, wherever the connections is required, that those water bodies get the flood water and then use that for the recharge. And that exercise, I think, we need to do it for each and every town. We need to do that for each and every village, okay, and make sure that number of water bodies are increased, and then those water bodies can be vertically recharging throughout the year. Yes. It's not just we recharge it during the monsoon period, 30-40 days. We have to make sure that the recharge takes place almost throughout the year. Okay, and then only we'll be able to compensate.
Well, and maybe with that, we can take a question now from the JJ School of Architecture here in Mumbai. I think we're just waiting on the sound. Just 1 second. Yeah, we're just having some. Sure. So we have, while we wait to get the sound updated, we have a question from one of our viewers. The question is: lower part of Ganga River Basin is associated with arsenic contamination. Is there any relation with groundwater extraction and infiltration of water into the ground? I think Dr. Tare.
Surely there is a relationship. What happens is if we extract more groundwater, there are white spaces which are created, right? And the top layer, if we have the anthropogenic activities like we keep on dumping our septic tank effluents, open defecation, sewage being used for agriculture purpose, irrigation purposes, and that actually enhances the biological activity in the top layer, and that is responsible for reducing the redox potential, because oxygen level goes down when you have the degradable carbon that is degraded or the nitrification that takes place, and that reduces the oxygen levels. And the moment you have oxygen level reduced, then the geochemistry changes. The iron and arsenic get reduced, and then they are immobile, otherwise they become mobile. So this anthropogenic activity is responsible. And then entire groundwater is connected, like we have some fissures. Normally we say, okay, how arsenic is coming into the deep tube wells, right? Now, this release actually takes place at the top layers, but then the entire groundwater is connected, and that is where we find some places, even in the tube aquifer, because of fissures or whatever that you have, the top layer water moves into the gutter, and then we find arsenic there as well. So yes, if you keep on extracting groundwater, we are actually changing the geochemistry there, and the change in geochemistry is what is responsible for mobilization of the arsenic, and more it is related with if you are also dumping your sewage, and this happens everywhere. Okay, and you will not necessarily say that, you cannot say that arsenic is there only where it gets released, because it may get released somewhere, but it travels all over, and that's why you find at places where there is no reason for release of arsenic, yet we find arsenic into the ground.
So, and maybe with that, then we can take another question while we wait on the sound from the National Institute of Hydrology in Roorkee.
Yes, Professor. In case of Ganga Basin, Babar and Terai belt, these are the
So while we're doing that, we have a question from JJ College, which is asking, there is 38,000 cubic meters per second of sediment coming through per year. So there is a continuous change in the Sundarban region, which is basically due to scouring of land along the length of Ganga. What will you suggest our strategy to take care about scouring of soil?
In fact, this problem has been recognized very well, and like we are investing as much as on the pollution control, sewage treatment, almost the similar kind of investment is envisaged to make sure that we give catchment area treatment, right? Like we are doing forestry interventions, and there is a big plan of the government of India. In fact, the Forest Research Institute is involved in that. They have made a detailed plan and a huge investment, and in some action has already been started, starting from not only in the Himalayan region, but also in the other places, right? How do we make sure that this is the soil erosion and other things is, and the only way that you have is you strengthen the soil, you reinforce, and the best way to reinforce the soil is you put trees there, okay, so that the erosion and other thing is controlled. And that's a big problem, obviously big problem, and huge investments are required.
Thank you very much.
And we have another question, a rather succinct question, which is dredging good or bad for a river?
Well, that's a I think we have to have a very organized and controlled way of doing things, right? Because making sure that the aquatic life is not disturbed, right? At the same time, even for aquatic life to survive, it is important that certain depth of the channel is maintained.
Sure.
Right? So it is both from this thing, and of course, where we are talking about navigation and things, that's very important, right? But we have to make some, these days the technologies are available, so we have to be careful, even if they are expensive, they are worth, because we cannot ignore the aquatic life in the river, and also make sure that the river's geomorphology is not changed. Okay, that is also very important aspect when we look at the dredging aspect. Okay, of course, it's not a very easy issue, and you cannot simply do this in Ganga and Yamuna rivers as we have done in other rivers. Our models are not applicable for Ganga and river, because the amount, as somebody just mentioned, the amount of silt that comes into Ganga Basin, particularly downstream of Varanasi, is huge. Okay. And it has to be done very strategically, with plan, and without proper, reliable information. Yes, and unfortunate part is right now we don't even understand that system well. We don't even have quantitative information on that. So I think effort should be made first to understand, to generate information, and only then we can take a call on where the dredging is possible, where we should do, to what extent we should do, and what kind of technology we should use for dredging.
Sure. So we certainly need more data to visualize that data, right?
Yes.
So maybe now we could take, I think, another question from the National Institute of Hydrology, Roorkee. It's a good sign. I hear sound.
I am Dr. Rinoj Thayan. I work mainly on glaciers and snow. But my question is, the health of the water machine is pretty bad at this point of time, and we know that the municipal and industrial waste are contributing to the deterioration of the health of this water machine. My one question is, how will we get a good mechanic to repair this machine? And second is, what do you think that which kind of pollution is more problematic for the Ganges system, whether it is municipal waste or it is industrial waste? Because most of the focus now is on the municipal waste rather than industrial waste. Thank you.
Well, I think if we are talking about pollution, in terms of the quantity, it is certainly the domestic sewage, which is more. But in terms of the difficulty and the strength, and in certain pockets, it is the industrial waste which is very important. And I think the steps are being taken now to make sure that the industries follow the norms that are prescribed. In fact, one of the lacuna or the gaps that you can say that we have not been able to implement the existing norms. Okay? So it's only a question of implementing the existing norms if they are implemented, and I think the government is taking the stricter actions. Very clear directions are given to the industries, and so that part has to be taken care of through the implementation of the existing norm. And when it comes to having mechanic, I think we need a large number of mechanics. One mechanic will not do this thing, and to that extent, every one of us has to be a mechanic, and we have to think about what happens to the toilet that I use. Where does it go? And am I really taking care of? And at the local level, we have to make sure that our wastes are taken, and are we really doing enough for that? And we should be actually forcing the municipal corporations, because we have to understand ultimately our health is affected because of that. Today, we do not understand the economics of it. If you treat sewage and make it almost to drinking water, it costs us not more than 1 paisa per liter. On the other hand, if you do not spend that 1 paisa, we end up paying 15 rupees or 20 rupees a liter for the same water. And today, why 15 years back, 20 years back, we were quite comfortable using any tap water, whether it is on railway station or public or whatever. Today, nobody drinks that water, and everybody spends 20 rupees per liter for drinking. Why have we come to that situation? Because I am afraid what I am drinking through the tap water is somebody else's fecal matter, or say. So that toilet to tap connection is what is we have to break. Okay, and that is we will have to understand that spending 1 paisa per liter is worth compared to spending 20 liters, and then making sure that everybody installs RO in their houses. I think we have to understand that economics, and the day we understand that economics, the whole scenario will change. And slowly, I guess that will happen. But I don't see that this will happen immediately in next 2 years, 3 years, or 5 years. we will have to develop that culture. And once we start, then it will move exponentially. Okay, but initially, I still don't see that this will happen in a big way in the next 3 to 4 years, 5 years, despite the big program of the government of India, Namami Ganga or whatever, unless until each citizen and each municipal corporation understand that it is their duty, and ultimately it has to, because everybody understands money, so it has to be read in terms of economic values, pricing, and the work that we get out of it.
Well, I would just add to that I think mechanic is a loaded word there, because I think that there's too much reliance on hard infrastructure when there's also a lot of room for soft infrastructures to address a lot of, especially the municipal wastewater that's entering into the Ganga as well, where there might be opportunities to do soft infrastructures like wetlands, bioswales in a lot of these nalas, as opposed to building sewage treatment plants, even decentralized ones in a lot of these contexts.
Even though, like you told, you're right, but that is also a mechanism, right? And for that also we need mechanics. Okay, even though it's a natural system or whatever, but we need people who understand
right,
this,
but I think
and the mechanics of that also has to be maintained properly.
Of course, but I think it's a very different mechanical model than what usually your discipline as engineers like, right?
Yes.
We have another question that asks us, should we look at Ganga as living being instead of a machine? And I would just say that, the idea of, we speak about humans or we speak about living creatures oftentimes as having a biological clock or even as a machine, that this idea that the mechanical is machine and that the organism is organic, there's been I think a lot of writing about, in fact, how all of us are cyborgs because of the amount of artificial implements that we've had put into us or done to us, prosthetics, etc. That the division between organic and inorganic, I think, is very much a false distinction today, or I would say less than false distinction. The difference between a machine and a living organism is increasingly harder to define, I would say. As a historian of science, I would say that.
Yeah, in fact, you're right. In fact, when we start teaching biology to the student, the way I say is all living organisms are nothing but chemical machines, right? So to that extent, even if you look at Ganga, it's a living thing, no doubt about it. But the living thing also has a mechanics of its own, right? Even your own body also, you have a pump, you have a complete piping system through which the circulation takes place. So in fact, all living organisms are nothing but machines.
Yes. Well, and I think that's a great note to end on, because we're at time. But I'd really like to thank Dr. Tare for coming to be with us here at the Columbia Global Center in Mumbai from IIT Kanpur. It's been wonderful to have you here to have this discussion. I also have to thank our incredible team here at the Columbia Global Center in Mumbai for doing a fantastic job. And also very much thank the National Institute of Hydrology in Roorkee, as well as JJ School of Architecture for participating here today. We very much enjoyed interacting with you as part of this webinar. Thank you very much.
Thank you.